going to prove that their area under the curve of little f of x dt has something to do with the antiderivative of f of t. So right now what I'm about to write is notation. The area from 0 to x, I'll use the dummy variable t, f of t dt. I define f of x, big F of x, to be that. Okay, that is, f of x is defined to be the area from 0 to x of f of t dt. Okay, f, big F and little f, they're not related at all yet. The integral of little f is not big F. We didn't show that yet. That's what we're going to show now. Okay. So now, if you consider consider f of x plus delta x. Well, that is the area from 0 to x plus delta x of f of t dt. Now, let us look at the difference of these two. What is that going to be? Well, let us draw that. What is f of x plus delta x minus big F of x? Well, so here's some function. I want to see one thing. Okay, here is 0, here is x, and here is x plus delta x. Well, f of x plus delta x is the area from 0 all the way up to x plus delta x. And the area f of x is the area from 0 all the way up to x. Well, it's saying from their yellow area in the graph, I'm supposed to take away the purple area. Okay. And what I'm left with is the area from x to x plus delta x. Okay, so this is equal to the area from x to x plus delta x, f of t dt. Again, what I'm writing on the right, all of this is just symbols. It has no connection to antiderivatives or has no connection. It's just symbols. Now, I choose to divide by delta x. So over here, I'll divide by delta x as well. Now, let us look at the area. Oh, good. Well, let us look at this area. This area is what's in blue and yellow. Now, by the mean value theorem for definite integrals, we know that there is a c. There is a c in x plus delta x. Say it's right here. There's c. Oops, that's c. Where? It's perfect to have this in front of me. Where? So this height is f for c. That is, this distance is f for c, and when you multiply it by the base, which is delta x, the base is delta x, and that's c. Okay, you get the exact area. you get the exact area. Okay, so this here is equal to, now what's in yellow is f for c times delta x times what's in blue. That is, divide by delta x. So we just get f for c. We get f for c, where c is in x. Let me use a little bit more space for that. Where that c is in x, x plus delta x interval. Okay. So right now we have the following. Let me write it down on one line. F of x plus delta x minus big F of x over delta x. This right here is equal to f for c, where c is in the interval x comma x plus delta x. Okay, so we have that. Now we're going to take the limit. We're going to take the limit. We're going to take the limit as delta x goes to 0. On the other side, we have to do the same. And on the left side, we get f prime of x. And on the right side, if delta x is going to 0, then x plus delta x is going to x. And c, let me write this c a little bit different. C is sandwiched in between x and x plus delta x. So as delta x goes to 0 in the limit, so if I take the limit as delta x goes to 0 there, I get x. And if I take the limit as delta x goes to 0 there, I get x. So as delta x goes to 0, this has to be x. It's jammed in between x and x. So this is f of x. Ooh, we got somewhere. We got somewhere. Look, so let me take the derivative of big F is little f. And if I integrate big F with respect to x, I get f of x. And if I integrate little f of x with respect to x, I get that. So there is the connection. It really is true that their integral of little f is that area function. Okay. Now, let's just go a little bit further. Let's go a little bit further. The integral from a to b, f for t dt, this, by definition of f, was f for b, big F for b, minus big F for a. Now, if you don't believe that, good. Let's see that it's true. So we have our function. Here is 0, here is a, here is b. So we want the area from a to b. Well, f for b is all of this. It clearly includes what we want. We want this. That's f for b. Now, we're going to take away f for a. But f for a is the area from 0 to a. And that's all I erased. The area from 0 to a. Now, we have some notation. And let's verify that our notation is correct. We say, well, the integral of f is big F, in this case f for t, and then we go from a to b. So the question is, did we define that notation correct? I mean, nobody can say, no, that's wrong. I mean, I could have defined it to be like that, and then I take f of the lower limit minus f of the upper limit. I could have said that it was f a t from a to b, a to b. I could have, it could not it could have been defined that way. But our notation is this, and we want to know if the notation is right. Well, that says, well, first plug in b into f minus, and then plug in a. Ooh, we get the same thing. This notation is correct. That finishes this video. Now you know that now you know their connection, or one can say connections, between little f and big F, where big F is associated with the area for little f. See you in the next video.